Thanks for inviting me. It's really great to speak at this conference. The energy's been awesome. So I was thinking when I was writing this talk, I heard about this talk format called What, Why, How. So I thought that sounds cool. So I'm basically going to give you a what, why, how talk. And this session is called AGI and Embodiment. And the title of my talk is Artificial General Intelligence, Human-like Intelligence, and Embodiment. And I thought maybe some of you don't even know what any of these words mean. You might not have heard of them before, so I thought I'd start with the what of this whole thing. So first of all, what is embodiment? Okay, so this is a picture of a little robot I have on my desk at work next to my computer, and it's a really, really simple robot. It's like probably the simplest robot you can build, and what we actually use it as is what's called a unit test robot. So every time we're creating a new neural net or a new piece of software, we run it on something like this to begin with and to see how things are going. And so this is the idea of embodiment. Is when you're developing software, you want to get it into the physical world as quickly as possible. So anytime you have an algorithm or a neural net or something like that, and you're putting it into a physical body, aka a robot, or a system that's a collection of sensors and actuators, you're embodying that AI. So that's what embodiment is, and I'm got quite attached to this little robot now. It's pretty cute, even though it's like really simple. Okay, so we know what embodiment is now. So what exactly are all these intelligences and learnings? What's like deep learning, machine intelligence, artificial general intelligence, deep reinforcement learning? What is this? So, okay, I was trying to understand this myself and put everything into context. So I thought I'd draw a diagram and share that with you today. So imagine this blue box is the space of all things that we as a civilization might consider problems. And I have to apologize here, because Max basically had almost the same diagram, and mine is nowhere near as good as his. He had this cool landscape with mountains and everything, and I've just got some dots. But we'll see how we can do. So each of these dots is a problem-solving technique that we've come up with as a civilization. Now, when we started solving problems as humans, we started creating different kinds of problem-solving techniques for every problem we encountered. What happened over time is we actually developed AI, and the cool thing about AI is it allows you to solve a slightly more general set of problems than having to handcraft a narrow problem-solving technique for every single problem you invent. This is cool. Some of these techniques are slightly more general than others. There are things like classifiers, support vector machines, natural language processing. There's lots and lots of different AI techniques. Some of them are more general than others, but they're all still trying to solve techniques in a slightly more general way than having to handcraft things. So what's AGI? What's artificial general intelligence? Well, I like to think of AGI as being a box that sort of surrounds this whole space. It's almost a hypothetical concept of an AI that could solve any problem. It could take on any problem and craft a solution to that problem. Now, AGI is sort of a sort of theoretical concept. We don't really have AGI, or I think everyone would agree we don't have anything that's at that level yet, but we have things that are approaching that level. So what's happened in the last few years is that there's been several disciplines within AI that have become big and taken over. And these are things like deep learning and reinforcement learning. And I think the reason that these have become so popular is because they're getting more and more general, and they're approaching that AGI. And now these circles are even starting to overlap with each other. But I want to talk about something slightly different today, still in this space, and that's human-like AI. I think human-like AI is actually something that encompasses lots of these other areas within AI. And I actually think human-like AI is not going to be true AGI, but it's the most general subset of AGI that we've encountered so far. So this is what I'd like to see in the future. What happens when you put embodiment and human-like AI together? You get human-like robots. I think in the future, a subset of the kind of AI we develop will be very human-like, not just in mind, but in physical appearance. So I often get asked, why on earth would you build embodied human-like AI? This is something people think has come from watching too many sci-fi movies. It's come from Hollywood. This isn't true AI. This is not really what AI researchers do. I'm going to disagree. I'm going to argue that the people that watch a lot of sci-fi movies are actually right. So, okay, why? So now I'm into the why section. So I'm going to give you some reasons why, and I really hope to convince you that human-like AI is coming. So the first reason we're going to build human-like embodied AI is an empirical answer. We just love creating things in our own image. You don't have to look very far into sci-fi to see that this is the case. And also, if we have something like the human form, we can use that as a milestone to get towards. We already have a blueprint for the kind of thing that we want to build, and we can see our progress towards that. Another answer is on a more practical note. Our world is designed for humans. Everything we interact with, from doorknobs to smartphones to airplane seats, are all designed with this human-centric design in mind. Now, we could decide as a civilization to change our entire infrastructure so that it's more amenable to AIs controlling it. But I think it's actually going to be cheaper, faster, and easier to build human-like AIs that can already interact with all this infrastructure we have in place. The third answer to the why question is slightly more philosophical. I don't want to go into the details, but there's a hypothesis known as the embodied cognition hypothesis, and one of its tenets is that if you build a system that has a different body type to you, that has different sensors, different actuators, it's actually never going to be able to communicate with you. And the reason for that is the way that we build up concepts in our mind, our model of the world, comes from all that data coming in through our sensors and our actuators. And if it doesn't match, then you're not going to have the same concepts in your mind as that other entity. And what that means is you can't form a common language. So I think having human-like AIs will actually help our communication with the AI race. And fourth, I want to riff on something that Max was talking about. So a lot of people are very concerned about AI safety. The answer to this is that if we build systems that look like us, that think like us, that act like us, it is the best way to ensure that those systems are going to be non-hostile to the human race. So if you think about it, if a robot has a body that looks somewhat like your body, it's going to have concepts like someone physically harming its body. So if you chop a robot's arm off, we want to craft systems that have the robot feel the same pain and take the same issue with that as you would as a human. So these systems are going to naturally share our values, and they're going to be able to empathize with our physical experiences and our problems that we have in the world if they are shaped like us and if they think like us. Okay, so now I've told you why human-like AI, I'm going to move on to how. So I'm going to give you the 3 secret ingredients to building human-like AI. Now, obviously, there's a lot more detail in these ingredients and how to put them together and create the cake of artificial general intelligence than I'm going to go into here, but I thought these ingredients might be a nice overview. So, number 1, to build human-like AI, it must have a human-like body. So here is an example of one of the robots we have in our lab at Kyndi. It's our largest, most expensive robot, actually. It's a full adult-sized humanoid robot. And the cool thing about this is it has a lot of the same sensors and a lot of the same degrees of freedom and actuators as a human body. So that's cool. So you can build these kind of things. You can put a lot of fun sensors on them. But there's a really important point I want to get to here, and that is how we control these things. So one of the things we do at Kyndi is we build teleoperation rigs to control humanoid robots in a very analogous way. So the reason this is really important when you're building human-like AI in robots is that imagine you have a humanoid robot and you want to prove that it's going to become a human-like AI robot. One of the things that you need to make sure is that the robot can physically do the tasks and the things that you want it to do. So if you have a human controlling a robot, and that robot can do any task that a human could do with their human body, then you've kind of taken that problem off the table. You've shown that that robot is going to be able to do anything a human can do in principle, and that's not an issue anymore. You've kind of solved the interface problem. So there's no AI in this at all yet. This is just humans controlling robots. And because this is a Market for Intelligence conference, I wanted to point out the huge market opportunity that just this number 1 ingredient technology gives you. If you can separate the human worker from the physical work by embodying them in a robot, it opens up a vast number of opportunities in the labor market, and there's a lot of arbitrage between people who live in very expensive areas and people who live in areas where it's cheaper to live, being able to work in different places and remotely. So even this first ingredient of Humanlike AI opens up a lot of opportunities. Second ingredient. To build Humanlike AI, it has to have a human-like brain. So one of the things that's interesting about the brain, a lot of people have been talking about kind of deep learning and reinforcement learning. I actually think human-like intelligence, as I mentioned before, is a collection of lots of these different kind of learning systems. And not just the modern sexy ones that you hear about, but the brain has a lot of specialists built in as well that have evolved that actually can be mimicked by quite simple pieces of AI or even if-then rules. So I think in order to build a human-like brain, you need to look at how the human brain really works and try and mimic each of these functional specialists and bring together all these hybrid types of AI into something that isn't just one giant inscrutable neural net, but something that really does mimic the way we think. The way we model the brain at Kindred is in a kind of layered way. So the way our brain evolved is we evolved reflexes to keep our body safe. We then, on top of that, evolved some more emotional-driven behaviors. Instincts are very important, and memory. None of these things really involve a lot of complex deep learning or a lot of abstract concepts, but they're critical for an animal to be able to move its body around and stay safe in the world, and it's really important. And then once you've got all that solved, you have a robot that has some form of common sense. You know, it's like a mouse or something. It can run around, it can hide, it can find food, it can stay safe, it can like not get its limbs cut off. That's really important. And then on top of that, that's laid the groundwork for you now to build a very thin but very important layer, which is what we all consider to be modern AI. I think of it as the equivalent of the cortex in the human brain. And then you can start looking at problems like language, complex visual perception, and things like that. Okay, so if you have this human-like robot and a human-like brain controlling it, and I should mention that the brain can also be trained using the data that came from those humans teleoperating the robot. And if you do this process continually, you might think, well, you can get to human-like AI just using those two things. Human-like body and a human-like brain that's been trained with data coming from the human. So if you had that, it would be an awesome system. You could automate almost all of human labor. But there's still something missing. Anyone have any ideas what the final ingredient is? I don't know. Okay, the final ingredient is to build human-like AI, it also must have human-like motivations and goals. And this is something near and dear to Rich's heart. So the problem with just having an AI in a human-like body that's been trained on human data is that it's only ever going to be able to create actions in the style of the data set it was trained on. So you can think about me sitting there teleoperating the robot for hours or weeks, and then that robot can then mimic that data using its AI, but it's going to produce things that are in the style of me, which, you know, is awesome in some respects, but is not in others. Like I can't play the trombone, for example. So what can you add to the AI system to take it beyond just the human training data that it's been given? And to do that, you need to give it motivations and goals. So where do these come from? Again, we're using the human-like system as a model here. And I argue that you can look at the human reward function and you can unfold it into a very complex set of goals and needs for the robot. So you think about the human reward function, like what do humans really desire? What are they motivated by? And you think about it very deeply. You might think, oh, you know, they want to pass on their genes or something like that. So that's cool. That's like a base goal you can start with. But then you can unfold that into a series of more complex sub-goals. So I like to use this example of the Maslow's hierarchy of needs from psychology literature. You have these basic physical needs, which are the kind of the ones that have the highest priority to take over when something really bad is going wrong in your environment. So, you know, an example might be you're really hungry. You've been out in the rain for 4 hours and you're really cold and you can't think of anything else. So you need to think about these physical needs first. And we can actually bake these into the reward functions in these robot systems. On top of that, you can then layer social needs. So you can have things like respect, inclusion, being part of a group, liking being in the presence of other robots or other humans. You can layer these things onto the reward function. And then on the very top, once you've done all that, you can start to put what we consider the pinnacle of human desires, which is these kind of intellectual self-actualization needs. The need to learn new things. The need to understand your environment more. The need to improve yourself. We can actually put all these into the robot systems too. Okay, so that was all sort of in theory, and I just wanted to give you a quick overview of where we are in the AGI community with respect to these three ingredients. So, okay, first, the progress on the body. We can build human-like and animal-like bodies that are pretty good. They've got a lot of sensors, they've got a lot of actuators, and actually even that little robot that I showed that sits on my desk that looks really janky and stupid, that thing has a lot more sensors and actuators on it than the AI we build can even use now. It's got like an HD webcam, it's got 2 microphones, it's got temperature sensors, it's got proprioception sensors. All this data is way more than we need to develop the kind of algorithms we're looking at. So that's good. The bad news is that it's not going to get us to human-like bodies. We really do need some better progress made in specifically haptic sensors and actuators to go on the robot bodies. So I'm hoping this is something that's going to come out of robotics mechanical research in the future. And actually, the good point about this is there's kind of a virtuous cycle going on here. If we can start getting AGI into robotic products and showing that there are market opportunities for these more animal-like intelligences out there, then more of them will be manufactured because people want them as products. The costs will fall, and this will become easier and easier as these robotic systems become more available to researchers. So progress on the body is going well. Progress on the brain. I think we're starting to respect the balance between just a single approach to AI and hybrid approaches where we have to mix and mingle different kinds of AI to build a complete brain. I think we're getting much better at that now. We're starting to understand that in our own brain there are a lot of innate behaviors that are basically coded for in our genome. We don't learn them. We don't learn how to walk. We don't learn how to breathe. It's coded in our genome. It's innate structure that develops in our brains. We need to do the same kind of thing for AI. That's going well. We're starting to realize it. We also have a lot of good quality training data available for these kind of hybrid modern AI systems. We can use a lot of data that come from the human body itself. However, and this is the big if, there are still a lot of unanswered questions in building a human-like cognitive architecture. Things like acquisition of language, high-level symbolic reasoning, learning from very few training examples. All these are problems that we maybe have some ideas how to start tackling, but we really don't have answers to at the moment. Okay, and progress on the motivation side. I think even realizing that this is a thing is amazing progress that we've made. We can take examples from human reward functions and put those into robotic AI systems, and it will allow us to craft really intricate motivation systems and goal systems for these robots. It's a very nascent field, but I think it's going to grow and be really big in the future of machine learning, so I'm excited about that. And on a con to this whole thing is that building AIs with reward functions similar to humans is good in one respect, but it also means we're going to end up building systems that are so like us that we find it unethical to experiment on them anymore. So I actually think this might end up being considered more like medical research than computer science very soon. So we have to watch out for some of those issues and regulate appropriately. But I'm actually hopeful about this because what it means is that we're really going to be making progress in that AI safety direction. If we know roughly what these things are like, they're going to be human-like, we know how to deal with the safety issues around that. Okay, so as a final thought, so I did the what, I did the why, I did the how, but you all might be thinking, isn't the why like the really important thing and you did this in the wrong order? So no, I did this on purpose because I wanted to tell you my why. I want to tell you the real reason that I find this super exciting and why I'm not worried about AI in the future. And this is my personal answer to the why question. I think if we make robots and AIs that are human-like, what's going to happen is we're actually going to be able to merge with them in the future. If they have a similar body to ours, they have the same goals, they have the same reward functions, and they have the same kind of data flowing, then it's going to make it easier for us to not just live amongst them, but actually become them. And I think that'll be a great thing for our civilization in the future. So thank you.